the Learner's Haven. 89.7, the Learner's Haven.
Hello everyone, good morning. It's a new day and a new learning will come on your way. Welcome to Learner's Haven here on Santa Ines Elementary School, simulcast over 89.7 Learner's Haven. Today, it's the second week of our mathematics on the air. Join me in this 25-minute full of fun and learnings. I am your teacher broadcaster, Darwin A. Ignacio, grade 6 mathematics teacher, saying good morning grade 6 learners, good morning parents, and guardians. Before we begin, I will give you a few seconds to get your learning materials, module, compendium of note, math notebook, pen, and extra pad papers for you to use. Please take your seat properly and stay in your most comfortable manner or position. Are you ready now? Our today's topic for Mathematics 6, Quarter 3, Week 2 is formulating the rule in finding the nth term using different strategies, such as looking for a pattern, guessing and checking, and working backwards. Let's take a look at the picture. What can you see? Yes, two learners having a conversation about a riddle. Let's listen to them. You look puzzled, Matt. Do you have a problem? It's this riddle in this book. On the first day, Humpty Dumpty collected 4 colored eggs. He collected 8 eggs on the second, 12 on the third, 16 on the fourth, and so on. How many colored eggs will he collect on the 10th day? Can you help Matt solve the riddle by looking for a pattern? Use a table to organize the data given. The table has 4 columns. The first column states the days. The second column states the number of colored eggs. The third column states the pattern. And the fourth column is the factored form. As you can see on the table, the first column has its counting numbers from 1 to 10. It states the days from day 1 up to day 10. The second column has the number of colored eggs collected by Humpty Dumpty. So this is called the term. On the third column, we can see the pattern for each day on the number of colored eggs collected by Humpty Dumpty. And the fourth column is the factored form. For day 1, the number of colored eggs collected by Humpty Dumpty is 4. So we can see that the pattern there is 4. Now, we can say that number 4 is a constant. On the second day, Humpty Dumpty collected 8 colored eggs. So the pattern is 4 plus 4. On the third day, the number of colored eggs collected by Humpty Dumpty is 12. So the pattern will be 4 plus 4 plus 4. On the fourth day, the number of colored eggs collected by Humpty Dumpty is 16, and the pattern is 4 plus 4 plus 4 plus 4. We have noticed that the pattern is addition of 4s to the previous term it follows. So we can say that on the day 10, the pattern will be addition of 4 10 times. So we will add 4 plus 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 4. Then we will get 40 as the number of colored eggs collected by Humpty Dumpty. So the answer to the riddle is Humpty Dumpty will collect 40 colored eggs on the 10th day. What if Matt is asked to determine the number of colored eggs that Humpty Dumpty will collect on the 45th day? Using the pattern, you have 4 multiplied by 45 is equal to 180. In general, the number of colored eggs that Humpty Dumpty will collect on the nth day is equal to 4n, or 4 times n. In this lesson, focuses on solving problems similar to this using what is called the nth term. Patterns are everywhere. Some situations you encounter every day follow a pattern. Your savings from your school allowance, the battery life of your phone, and your running speed at different times can all follow a pattern. In mathematics, a sequence is a list of numbers or objects following a rule or set of rules called a pattern. Each element in a sequence is called a term. In the first sequence, 4, 8, 12, 16, and so on, the first term is 4, the second is 8, and so on. In the situation a while ago, the expression 4n, representing the number of colored eggs that Humpty Dumpty will collect on the nth, is called the nth term of 4, 8, 12, 16, and so on. The nth term of a sequence is a general expression used to determine the number in the nth position of a sequence. Example number 1. Determine the rule for the nth term of the sequence 6, 12, 18, 24, 30, and so on. Step 1. Organize your data in a table. Step 2. Look for the pattern. Notice that the number 6 is always added to the previous term to get the next term. The first term is 6, so when we add 6, we get the second term, which is 12. When we add 6 to number 12, we get the third term, which is 18. Step number 3. Rewrite each term as a sum of 6's following the pattern in step 2. The first term is 6, so the pattern is 6. The second term is 12, so the pattern is 6 plus 6, which is equal to 12. The third term is 18, which is the pattern is 6 plus 6 plus 6. The fourth term is 24. 6 plus 6 plus 6 plus 6. And the fifth term is 30. 6 plus 6 plus 6 plus 6 plus 6. Step number 4. Write the pattern in factored form. As you can see on the table, term number 1 has a term of 6 and the pattern is 6. So we can say that the factored form for term number 1 is 6 multiplied by 1. Now to find the nth term of a number, the rule is 6 multiplied by n. Therefore, the nth term of the sequence 6, 12, 18, 24, 30, and so on is 6n, or 6 multiplied by n. In other cases, the nth term is expressed in more complicated forms. For example, 6n plus 3, 2n minus 5, or 5n plus 1. This is because a term cannot be expressed as simple product of a real number and the corresponding term number. Next example. From his daily allowance, Math saves for PB's birthday. He saved 1 peso on the first day, 6 pesos on the second day, 11 pesos on the third day, 16 on the fourth day, 21 pesos on the fifth day, and so on for 15 days. Determine the rule for the nth term that describes Math's savings after n days. Step 1. Find the pattern for the number sequence. The number sequence is 1, 6, 11, 16, and 21. Notice that adding 5 to the previous term gives the next term. Step 2. Express each term using 5 and another number. As you can see on the table, we have the term number, the term, and the pattern. For term number 1, the term is 5. So we can express this term using 5 minus 4. On the second term, the term is 6. So when we use 5 plus 5 equals 10 minus 4, we get number 6 for our second term. Step 3. Write the pattern in factored form. So for the first term, the factored form is 5 multiplied by 1 minus 4. To find the nth term, we are going to use the factored form 5n minus 4. Thus, the rule for the nth term of Math's saving is 5n minus 4, or 5 multiplied by n minus 4. For our next example, determine the nth term of the number sequence 7, 11, 15, 19, 23, and so on. Step 1. Find the pattern for the number sequence. You see that adding 4 to the previous term yields the next term. The first term is 7. Added 4 is equal to 11, which is our second term. Step number 2. Rewrite each term as a sum of 4s. Think of a number that can be added to 4 to get our first term, which is 7. Correct. 3 can be added to 4 to get our first term, which is 7. So for our second term, which is 11, we are going to add our constant number, which is 4, twice. 4 plus 4 equals 8 plus 3 equals 11. So for term number 5, we are going to add number 4 5 times, added to number 3 to get the fifth term, which is 23. Step number 3. Write the pattern using a factor of 4. So as you can see on the table, the factored form for our first term is 3 plus 4 multiplied by 1. So to get the nth term, we are going to use the factored form 3 plus 4n, or 3 plus 4 times n, which stands for the term number. Therefore, the rule for the nth term of the sequence is 3 plus 4n, or 4n plus 3. Let us do another example. Phoebe cracks a joke to two of her friends on the first day. On the second day, 4 people already know the joke. On the third day, 8. On the fourth day, 16, and so on. Determine the nth term of the sequence that describes the number of jokes of people who knows Phoebe after n days. Step number 1. Find a pattern for the number sequence 2, 4, 8, 16, and 32. Always multiply by the number 2 to get the terms of the sequence. 2 times 2 equals 4, 4 times 2 equals 8, 8 times 2 equals 16, and 16 multiplied by 2 equals 32. Step 2. Write the terms of the sequence as factors of 2. As you can see on the table, the first term is 2, so we will write 2 for the pattern. Remember, 2 is our constant number. For the second term, which is 4, we are going to multiply 2 times 2. For our third term, we are going to multiply 2 times 2 times 2. For number 4, we have the term 16 by multiplying 2 times 2 times 2 times 2. And the last term will be 32 by multiplying 2 times 2 times 2 times 2 times 2. For step 3, write the pattern in exponential form. As you can see on the table, the first term has an exponential notation of 2 to the first power. Therefore, the nth term of the sequence is 2 to the nth power. For our last example, determine the rule for the nth term of the sequence 4, 10, 28, and so on. If 1 is subtracted to each term, the resulting sequence includes powers of 3, that is 3, 9, 27, and so on. Thus, write the pattern using factors of 3. For term number 1, we are going to use the exponential notation 1 plus 3 to the first power. Therefore, the nth term of the sequence is 1 plus 3 to the nth power. Now, open your activity sheets on page 7 and let us answer it one by one. Determine the next number in the following number sequence. The first one is 1, 5, 9, 13. What is the fifth term of the number sequence? So when we add 4 to the previous term, we can get the next term. If you answer 17, you got the correct answer. For number 2, the number sequence is 4, 7, 10, 13, blank. By adding 3 to the previous term, we can get the next term. So what is your answer? When you answer 16, very good, you are correct. Our number sequence for number 3 is 2, 8, 32, 128, blank. Are you ready? If you multiply the previous term by 4, you will get the next term. So what is the answer? Very good, it's 512. Number 4. Our number sequence is 20, 17, 14, 11, blank. What would be the next number? If you subtract 3 from the previous term, you can get the next term. If you answer 9, you are correct. Here is our last number sequence. 3, 8, 13, 18, blank. Are you ready? If you add 5 from the previous term, you will get the next term. So what will be the answer? Very good. The answer is 23. In summary, the following are the steps in finding the nth term of a number sequence. First, study the number sequence. Look for the pattern. Check if adding or multiplying a common number and the previous term will help you obtain the next term. Next, organize the data in a table. And finally, find out the relationship between the term, and constant number being added or multiplied. Congratulations, children! I know you have learned a lot today. What about a round of applause for the work well done? Ready? Clap! Continue answering the remaining items in your activity sheet on page 8 to be checked next meeting. Keep up the good works. Again, attend, listen. I hope you have learned a lot today. I am Darwin A. Ignacio, your grade 6 mathematics teacher. Until next time, goodbye.